5-letter words are formed using letters A, B, C, D, E, F, and G. So there's 7 letters. How many such words are possible for each of the following conditions? No condition imposed. No letter can be repeated. Each word must begin with the letter A. The letter C must be at the end, and the second letter must be a vowel. So to find the possible outcomes for 5-letter words using these 7 letters, we're going to use the counting principle, which is basically total outcomes equals M times N, or just all the possible outcomes for each thing multiplied together. So in this case, the total possible outcomes would be the outcomes for the first letter times the outcomes for the second letter times the outcomes for the third letter, and so on and so forth. So the first one is no conditions on the letters, which means that letters can be repeated. So the total outcomes would be 7 possible outcomes for the first letter, A, B, C, D, E, F, or G. And since letters can be repeated, 7 for the second letter in the 5-letter word, and 7 for that for the third, fourth, and fifth. So there's 7 possible outcomes for each in the 5-letter word. This is just 7 to the 5th power, which we can find with Desmos. 7 exponent 5, 16,807 possible outcomes for a 5-letter word when we can choose from 7 letters. Part B says no letter can be repeated. No letter repeated. So that means that for the first letter, there are 7 possible outcomes, but then there's only 6 for the second letter because we can't repeat the outcome for the first letter. And then only 5 for the third letter because we can't repeat the outcome from the first and second letters. And then 4, and then 3. Find this on Desmos. 7 times 6 times 5 times 4 times 3. That's 2,520 possible outcomes if no letter can be repeated. For C, we have begins with the letter A. So the first letter in the 5-letter word has to be A. So there's only 1 possible outcome for the first letter. 1 for the first letter, and then no conditions are placed on the other, so there's 7 possible outcomes for the other 4 letters. So this is 7 to the 4th power, which equals 2,401 possible outcomes for a 5-letter word where the first letter is A. D says the letter C must be at the end, so ends with a C. Ends with the letter C. So the total outcomes, there are 7 possible outcomes for every letter except for the last letter. So 7 times 7 times 7 times 7, and then there's only 1 possible outcome for the last letter, C. So this is also 7 to the 4th power, which we already know is 2,401. And part E, the second letter must be a vowel. So, second letter, a vowel. Based on the 7 choices that we have. So there's only 2 vowels in these 7 choices. So that means that there are 2 outcomes for the second letter. Total outcomes equals 7 possible outcomes for the first letter because there's no conditions imposed on the first letter. But there's only 2 possible outcomes for the second letter because it has to be a vowel. And 7 for the rest of the letters in the 5-letter word. So this would be 2 times 7 to the 4th. 2 times, so we have 7 times 2 times 7 times 7 times 7. 4,802 possible outcomes if the second letter is a vowel. So this is how we do the basic counting, finding possible outcomes for a 5-letter word.